At precisely 2116 West 106th Street in Cleveland, Ohio, the month of November 1912 didn't just bring the usual autumn chill. It brought the birth of an industrial titan. A small, unassuming manufacturing plant opened its doors to a world that had no idea what was about to happen inside those brick walls. The building didn't just exist, it breathed. It smelled of heavy cutting oil, hot metal shavings, and the sharp ozone tang of early industrial electricity. Outside, the world was moving at a different pace. The streets of Cleveland were quiet, disturbed only by the occasional wooden spoke wheels of an automobile rattling over the cobblestones. But inside, a handful of workers were engaged in a craft that would one day dictate the fate of empires. They were assembling marine gasoline engines, following meticulous blueprints drawn by a man named Alexander Winton. Now, you have to understand who Winton was. He hadn't just made a fortune, he had pioneered the American dream, building some of the first successful automobiles in the United States. He was a man of the road, yet his mind was increasingly drifting toward the sea. Cars were a novelty, a luxury for the few, but engines, the raw internal combustion of power, were a fascination that bordered on obsession for him. Winton wanted to build something that wouldn't just last a Sunday drive. He wanted to forge machines that would power massive hulls through the crushing resistance of the Atlantic. By 1913, just a year after those doors first creaked open, Winton achieved the impossible. He built America's first diesel engine. This wasn't the very first diesel in the world. That honor sat across the ocean with Rudolf Diesel in Germany. But this was the first one birthed on American soil, shaped by American hands. It was a four-stroke beast, heavy, slow, and remarkably inefficient by the standards of the jet age, but it possessed a fundamental reliability that changed everything. It burned fuel oil, a substance far cheaper and infinitely safer than the volatile gasoline used on ships at the time. As that first engine rumbled to life, shaking the very foundations of the factory floor, Winton knew he had captured lightning in a bottle. If you find yourself captivated by these forgotten origins, the stories of the grease and grit that built the modern world, subscribe to our channel. We go where the textbooks don't, into the dark corners of history where the real work was done. By 1916, the growth was undeniable. The modest operation was rechristened Winton Engine Works. The plant was no longer a small gathering of enthusiasts. It was an army of over 100 men. They lived in a symphony of mechanical violence. The screech of machining pistons, the deep hollow bore of cylinders, and the rhythmic clanging of crankshafts being balanced by eye and hand. It was loud, it was dangerous, and it was terrifyingly precise. In that era, a single mistake in a measurement, a fraction of an inch off, could mean more than just a ruined engine. It could mean a catastrophic failure in the middle of a gale, a death sentence for a crew thousands of miles away. These engines weren't for glamour. They were for the tugboats, the fishing fleets, and the small, uncredited craft of the Navy. Reliable machines doing the work that nobody wanted to talk about, but everyone depended on. As the calendar turned to the 1920s, the world was changing, and the Winton Engine Works was at a crossroads. In 1928, a man named George W. Codrington stepped through the doors to become president. You have to understand Codrington. He wasn't a silver-tongued salesman or a corporate suit looking for a quick profit. He was an engineer in the most visceral sense of the word. He didn't believe in marketing slogans or polished promises. He believed in the cold, hard divinity of numbers. Under his cold-eyed leadership, Winton began to push the boundaries of what a diesel engine could be. They moved away from the heavy, lumbering designs of the past and toward a future of lighter, faster, two-stroke engines, designs that squeezed more raw horsepower into every cubic inch of steel. These were engines designed for the claustrophobic reality of a submarine hull, where space was more precious than gold. Then came 1930, the year the trajectory of American industry shifted forever. General Motors, the gargantuan titan of Detroit, looked at the small plant in Cleveland and saw not just a factory, but the future of mobile power. GM bought the company, rechristening it the Winton Engine Corporation. But the acquisition didn't bring a slow, bureaucratic death. Instead, it was like pouring high-octane fuel onto an open flame. GM didn't just want to build engines, they wanted to dominate the very concept of the diesel cycle. They poured millions into research and development, hiring a new breed of engineers and doubling the size of the factory floor. By 1938, the transformation was complete. The name changed one last time to the Cleveland Diesel Engine Division of General Motors. The plant now spanned several city blocks, a sprawling empire of brick and glass. The workforce had swelled to over 1,000 men, but the engines they were building were no longer intended for the quiet commerce of tugboats or fishing vessels. The air in the plant had changed. It tasted of urgency. These machines were being bred for a singular, violent purpose. They were being built for war. December 7th, 1941. A Sunday morning in paradise that turned into a landscape of fire and twisted metal. In a single, devastating strike, the United States Navy lost 8 battleships. Over 2,000 American lives were extinguished in the smoke of Oahu. The Pacific Fleet, the primary shield of the nation, lay broken and burning. The era of the battleship was dying in the flames, and the Navy's Bureau of Ships knew it. They didn't need more slow-moving steel fortresses. They needed sharks. They needed submarines to cut the enemy's throat, and they needed them now. Within weeks of the attack, urgent top-secret contracts landed on the desks at Cleveland Diesel. The Navy didn't just ask for engines. They demanded a miracle. They needed hundreds, then thousands of power plants for submarines, destroyers, and the countless landing craft that would eventually storm the beaches of the Pacific. But the math of war was cruel. Before Pearl Harbor, Cleveland Diesel was a boutique operation producing perhaps 50 high-quality engines a year. 50 engines won't win a global conflict. The Navy needed thousands, and they needed them in months, not decades. On a bone-chilling January morning in 1942, George Codrington stood on the factory floor and looked at his 1,000 men. He was an engineer. He did the calculations in his head. Even with every man working until they collapsed, the current plant was a drop in the ocean of the Navy's demands. So he did what American industry does best. He expanded with a vengeance. GM purchased every acre of adjacent land. New buildings rose from the mud in a matter of weeks, not months. Assembly lines stretched until they disappeared into the industrial haze. By the end of 1942, the workforce had exploded to 5,000 souls, men and women working 3 shifts, 24 hours a day, 7 days a week. The plant at 2116 West 106th Street was no longer just a factory. It had become a city within a city, a 24-hour furnace of production that never saw the sun set. The sheer explosive growth of Cleveland Diesel's workforce wasn't just a number, it was a revolution in human capital. Most of the new 5,000 had never touched an engine before. They were farm boys, from the sleepy fields of Ohio, drawn by the promise of wartime wages and a deeper sense of duty. They were factory workers from the automotive giants of Detroit, temporarily reassigned to a different kind of horsepower. And crucially, they were women, thousands of them, who had once been seamstresses, school teachers, or homemakers, now thrust into a world of molten metal and roaring machines. Cleveland Diesel became a brutal, unforgiving university of precision. New recruits were trained in weeks, not months. There was no time for gentle learning curves. The Navy needed engines yesterday. They learned to read blueprints that looked like hieroglyphs, to measure tolerances to the thousandth of an inch, a margin of error so small it was invisible to the naked eye, yet critical to survival. They assembled engine blocks weighing several tons, each component a testament to industrial might. The training was less about teaching and more about forging resilience. The stakes were too high for failure. Ships were being sunk in the black waters of the Atlantic, and American submarines were battling for survival in the vast, unforgiving Pacific. Every day without an engine was another day the war continued. Another day that a son, a brother, a husband might not come home. The workers understood this with a visceral clarity. They showed up before dawn, their footsteps echoing in the pre-morning darkness. They worked through lunch, often eating stale sandwiches beside their clattering machines. They stayed late into the night under the harsh, unforgiving glare of industrial lights that turned the factory floor into a dystopian landscape of shadows, sparks, and relentless motion. The noise was a constant, deafening symphony, the incessant hammering, the high-pitched whine of drills, the guttural grind of metal, and the explosive roar of engines being tested. The smell of hot metal, cutting oil, and diesel fuel soaked into their clothes, their hair, their very skin, becoming an indelible part of their being. But they kept working, driven by an invisible thread of duty. Consider Robert Kowalski, a machinist who spent his night shifts from 1942 to 1945 operating a boring machine. His job was to carve out engine cylinders, each one required to be exactly 8.75 inches in diameter. Any variation, even a few thousandths of an inch, and the engine would fail, possibly costing lives. Kowalski worked in clouds of fine metal dust, the air thick and choking. The machine ran hot, radiating an oppressive heat, while in winter the factory floor was freezing, and in summer, suffocating. He wore goggles and a respirator, but the dust still got into his lungs. He'd cough up black phlegm for hours after his shift ended. He never missed a day. Years later, when asked why, his reply was starkly simple. My brother was on a destroyer in the Pacific. If the engines failed, he died. So the engines couldn't fail. That was the unspoken creed. Then there was Margaret Hensley. Before the war, she was a school teacher, her days filled with chalk dust and children's laughter. Cleveland Diesel trained her in 3 weeks, transforming her into one of the plant's best welders. Her critical task was to seal the internal chambers of engine blocks, creating airtight, perfect welds. One weak spot, and the engine would leak oil or coolant under immense pressure. One mistake, and a submarine's engine room could flood, turning a patrol into a tomb. She worked 12-hour shifts, her hands scarred from burns, her arms aching from holding the heavy welding torch steady. But her welds never failed inspection. When the war ended, she quietly returned to teaching, never speaking of the factory. For these unsung heroes, it wasn't about glory, it was about work. Hard, brutal, necessary work done in the shadows. The heartbeat of the American submarine fleet was not a man, it was a machine. Specifically, it was the Cleveland diesel model 278A. To an outsider, the name meant nothing. To a submarine captain patrolling the icy depths of the Pacific, those numbers meant survival. This was a two-stroke V-type diesel, a marvel of wartime engineering. Its massive frame housed 16 cylinders, arranged in two banks of 8. Each cylinder boasted a bore of 8.75 inches and a stroke of 10.5 inches, translating into a rated power output of 1,600 horsepower at 750 revolutions per minute. To comprehend the sheer scale of this mechanical beast, imagine an engine weighing over 30,000 pounds, standing nearly 10 feet tall, a metallic leviathan engineered for the abyss. What made the 278A legendary was not its raw power alone, but its unyielding reliability. It was designed to run for days without stopping, a tireless workhorse in an unforgiving environment. It could withstand the bone-jarring vibration of depth charges exploding nearby, a testament to its over-engineered durability. Operating in saltwater environments, where lesser machines would quickly corrode into scrap, the 278A was built to resist, its cylinder liners chrome-plated for ultimate endurance. But perhaps its most crucial feature was its repairability. In the vast, isolated expanses of the Pacific, a disabled engine meant a dead submarine. The 278A was designed with modular construction, allowing it to be repaired at sea with basic tools and a limited supply of spare parts. Reliability wasn't a luxury, it was the absolute, non-negotiable requirement for every engine leaving Cleveland. A submarine on patrol was a creature of two worlds. Underwater, it moved silently on battery power, a ghost hunting in the deep. But those batteries had a finite capacity, typically only enough for a few hours of high-speed submerged operation. To recharge them, the submarine had to surface, usually under the cloak of night. And when it surfaced, the diesel engines had to ignite instantly, every single time, without fail. If an engine refused to start, the submarine couldn't recharge its vital power source. It became a sitting target, a metal coffin waiting for the dawn and enemy aircraft. Cleveland Diesel understood this terrifying reality down to its core. Every single 278A engine that left the factory was subjected to hours of brutal testing. It was run at full power, pushed to its absolute limits, simulating the worst conditions a submarine might face. Only after passing every single test, with zero tolerance for failure, was it carefully crated, loaded onto a train, and shipped to a naval shipyard. This wasn't merely quality control, it was a pact of survival. It was the promise that the men beneath the waves could trust the beating heart of their vessel with their very lives. To grasp the true impact of Cleveland Diesel, you have to look past the grease and the noise and stare directly at the brutal, unyielding mathematics of war. From July 1939 through the final echoes of gunfire in December 1945, the factory at 2116 West, 106th Street, performed a feat of production that defied industrial logic. They didn't just build parts, they built 13,640 complete, battle-ready engines. Break that down, and the reality is staggering. An average of nearly 6 massive engines every single day, for 6 straight years, without a single day of rest. The diversity of this output was its strength. They produced nearly 2,000 of the 16-cylinder 278A giants, hundreds of the 12, 8, and 6-cylinder variants, and over 9,000 units from the 268 series. These weren't just engines. They were the collective pulse of the United States Navy. These 13,640 machines provided the lifeblood for 5,562 naval vessels. They powered 399 destroyers hunting U-boats in the Atlantic, 1,817 landing craft that carried the weight of liberation to the beaches of Normandy and Iwo Jima, and over 1,100 submarine chasers. But the most staggering statistic, the one that defined the war in the Pacific, is this. Cleveland diesel engines powered an estimated 70% of the U.S. Navy's submarine fleet. 7 out of every 10 American submarines that prowled the deep were running on Cleveland steel. Famous boats like the USS Tang, the USS Wahoo, and the USS Harder, vessels that became legends for their aggression and survival, all shared the same mechanical DNA. These submarines were responsible for sinking over 2,300 Japanese ships, effectively severing the empire's jugular by cutting off fuel, food, and ammunition. Historians estimate that American submarines accounted for more than half of all Japanese shipping losses. And most of that destruction was made possible by the reliability of an engine built by people in Ohio who had never seen the ocean. This wasn't just manufacturing, it was the silent architecture of victory. When the smoke of World War II finally cleared, the industrial furnace of Cleveland diesel didn't flicker out instantly, but the world it had built was fading. The site at 2116 West 106th Street, once a 24-hour cathedral of fire and precision, is gone now. Today, if you visit that address, you won't find a plaque, a memorial, or even a rusted girder. You will find a parking lot. There is nothing to tell the thousands of people who park their cars there every day that they are standing on the very ground where the heartbeat of the Pacific was forged. Most people in Cleveland don't even know the plant existed. But while the buildings are gone, the engines, those iron miracles, remain. Some are still working, powering old tugboats on the Great Lakes, their deep rumbles a surviving echo of the 1940s. Others exist as floating memorials. If you visit the USS Cod, a Gato-class submarine moored in Cleveland, you can walk into the engine room and stand inches away from the original Cleveland diesels. They are 80 years old. They are encrusted with history and the smell of ancient oil. Yet if you were to fuel them and turn the key, they would still roar to life. That is the legacy of Cleveland diesel. Reliability that outlives its creators. The impact of this factory lives on in ways we rarely see. Modern diesel technology, the engines in our ships, trains, and hospital backup generators, owes its DNA to the innovations perfected in that Cleveland plant. Two-stroke uniflow scavenging, modular construction, and unit fuel injection weren't just wartime improvisations. They were the blueprints for the modern world. The workers, the Robert Kowalskis and Margaret Hensleys, went home when the war ended. They didn't ask for parades, they didn't get medals. They just carried the quiet satisfaction of knowing that when it mattered most, their engines didn't fail. Deep in the Sea of Japan, inside the rusted hull of the USS Wahoo, those engines still rest, silent and encrusted with 8 decades of marine growth. The builder's plates are still there, stamped with "Made in Cleveland, Ohio." They are monuments to a generation that didn't just fight for freedom, they built it, one piston at a time. The factory is a parking lot, the workers are gone, but the victory they fueled is the air we breathe today. If a legacy built on sweat and precision is worth remembering, then their story must never be forgotten.